Our planet faces a critical challenge. As we look down from space, the beauty and fragility of Earth become clear. Every continent, every ocean, every city is part of a delicate balance that sustains life as we know it. Humanity's progress has always depended on energy. From the first flicker of fire to the dazzling lights of our modern cities, our need for energy has only grown. Today, billions of people rely on electricity to power their homes, businesses, and dreams. We need energy, lots of it. And as our population grows and technology advances, our demand for energy will only increase. But the way we produce most of our energy comes at a steep cost. Our current energy sources, many based on fossil fuels like coal, oil, and natural gas, threaten our very existence. These fuels have powered the Industrial Revolution and modern life, but they also release harmful emissions into the atmosphere. They pollute our air, water, and land. Toxic chemicals seep into rivers, smog clouds our cities, and waste piles up in landfills. The consequences are visible everywhere, affecting our health and the environment. Even more alarming, these emissions drive climate change with devastating consequences. We see stronger storms, rising sea levels, wildfires, and melting ice caps. The stability of our climate and the future of generations to come is at risk. Clearly, we need a new path. A clean and sustainable energy source is essential for our survival. Innovation is the key. Around the world, visionaries are working tirelessly to develop new technologies that can power our lives without destroying our planet. Scientists and engineers from every corner of the globe are searching for this energy solution. They collaborate across borders, sharing knowledge and breakthroughs, united by a common goal, to secure a better future for all. Among the most promising frontiers is fusion energy, the same process that powers the sun and stars. Fusion has the potential to provide nearly limitless clean energy, using abundant fuels and producing minimal waste. If we can harness it, fusion could transform our world. Imagine a world where energy is clean, safe, and virtually inexhaustible. Fusion could make this vision a reality, lighting up cities and powering industries without polluting the air or warming the planet. China, a nation at the forefront of technological advancement, has embarked on a remarkable journey to harness the power of fusion. With vast resources and a commitment to innovation, China is investing heavily in research and development, determined to lead the way in this new era of energy. The Xinghuo project, meaning spark in Chinese, represents their bold vision for a brighter, cleaner future. This ambitious initiative brings together top scientists, cutting-edge technology, and a spirit of determination to unlock the secrets of fusion. It's a spark that could ignite a revolution in energy production. If successful, the Xinghuo project could inspire the world, proving that with innovation and collaboration, we can overcome the energy challenge and build a sustainable future for all. The Xinghuo project is not just another fusion experiment, it's a daring leap forward, a leap that combines the power of fusion with the established technology of fission. This fusion-fission hybrid approach is what makes Xinghuo so unique, so potentially game-changing. Imagine a future where power plants produce abundant energy. Energy that's clean, safe, and available to everyone. That's the promise of Xinghuo. A promise that has captivated the imagination of scientists and policymakers alike. But what exactly is fusion-fission hybrid technology? How does it work? Let's delve into the heart of this revolutionary approach. Fusion, the process of fusing atomic nuclei together, releases tremendous energy. Think of the sun, a giant fusion reactor in space. Fission, on the other hand, is the splitting of atoms, a process used in existing nuclear power plants. Xinghuo ingeniously combines these two processes. Here's how it works. First, fusion reactions generate high-energy neutrons. These neutrons then bombard a blanket of fertile uranium or thorium. This bombardment triggers fission reactions, releasing even more energy. It's like a two-stage energy booster rocket, amplifying the output. But that's not all. This hybrid approach also reduces the amount of nuclear waste produced compared to traditional fission reactors. It's a win-win situation: more energy, less waste. But achieving fusion is no easy feat. It requires incredibly high temperatures and pressures. That's where superconducting magnets come in. These technological marvels generate powerful magnetic fields, confining and controlling the superheated plasma where fusion occurs. Think of these magnets as invisible cages holding the raging inferno of fusion reactions in check. Xinghuo utilizes advanced high-temperature superconducting materials for these magnets. These materials allow for stronger magnetic fields and increased efficiency. This is cutting-edge technology, pushing the boundaries of what's possible. And China is at the forefront, developing and implementing these superconducting magnets for Xinghuo. When it comes to nuclear fusion, one of the most important metrics that scientists and engineers use to gauge the success of a reactor is something called the Q value. This single number can tell us a lot about how close we are to achieving practical, sustainable fusion energy, a goal that has eluded researchers for decades. In simple terms, Q represents the ratio of the energy produced by the fusion reactions to the energy that's put into the system to keep those reactions going. If the Q value is less than 1, it means the reactor is consuming more energy than it generates, which isn't sustainable for power generation. But if Q is greater than 1, the reactor is actually producing more energy than it uses. A crucial milestone that marks the transition from experimental science to a potentially revolutionary energy source. Achieving a Q value above 1 is a huge scientific achievement, but the higher the Q, the more efficient and practical the reactor becomes. For example, a Q value of 10 means the reactor produces 10 times more energy than it consumes. This is the target for many leading international projects, and reaching it would be a major breakthrough for the field. But the Xinghuo project in China is setting its sights even higher. Their goal is to achieve a Q value of 30, meaning the reactor would generate 30 times the energy it consumes. This is an incredibly ambitious target that, if reached, would set a new global standard for fusion energy research. To put this into perspective, the internationally renowned ITER project, which brings together scientists from all over the world, is aiming for a Q value of 10. Xinghuo's target of 30 not only surpasses ITER's goal, but also demonstrates China's determination to lead the world in fusion technology and innovation. If Xinghuo succeeds in reaching this ambitious Q value, it would represent a true paradigm shift in the field of fusion energy. It would mean that clean, virtually limitless power could be within our grasp, fundamentally changing how we think about energy production and consumption on a global scale. This bold goal is a clear reflection of China's commitment to pushing the boundaries of what's possible in fusion science and technology. It shows their willingness to invest in the future and to take on challenges that could benefit not just their own country, but the entire world. Ultimately, Xinghuo's ambitious Q value is more than just a number. It's a testament to the belief in the transformative power of fusion energy. If successful, it could usher in a new era of clean, sustainable power for generations to come. The heart of the Xinghuo project lies in Hefei, China, home to the Institute of Plasma Physics. Here, amidst state-of-the-art facilities, scientists and engineers are working tirelessly to bring Xinghuo to life. The project is currently in the assessment phase, with construction expected to begin in the coming years. The estimated cost of Xinghuo is substantial, which honestly is a testament to China's commitment to clean energy innovation. But the potential returns, both environmental and economic, are immeasurable. The world is watching as Xinghuo takes shape, eager to witness the advancements and breakthroughs that will emerge from this ambitious endeavor. China, the world's most populous nation, has a vested interest in clean energy. Xinghuo is not merely a scientific pursuit, it's a strategic imperative. By pioneering fusion-fission hybrid technology, China aims to reduce its reliance on fossil fuels and combat air pollution. The successful development of Xinghuo would position China as a global leader in clean energy. It would demonstrate their commitment to addressing climate change and building a more sustainable future, not just for China, but for the world. Xinghuo has the potential to inspire other nations to accelerate their own clean energy efforts, sparking a global transition towards a more sustainable future. The implications of Xinghuo extend far beyond China's borders. This ambitious project is not just a milestone for one nation, but a leap forward for all of humanity. As we look at our planet from above, it becomes clear that the challenges we face, climate change, pollution, and energy scarcity, are global in nature, requiring global solutions. Imagine for a second a world powered by clean, safe, and abundant fusion energy. Picture cities that never sleep, their lights fueled by a limitless source that produces no harmful emissions. Fusion energy, unlike traditional sources, offers the promise of powering our homes, industries, and transportation systems without depleting natural resources or endangering our environment. A world free from the shackles of fossil fuel dependence and the threat of climate change. In this future, the air is clean, the skies are clear, and children can play outside without fear of pollution. The health of our communities and the stability of our climate are no longer at risk from carbon emissions or toxic byproducts. This is the future that Xinghuo could help create. By unlocking the power of the stars here on Earth, Xinghuo represents a turning point, a moment when science and innovation come together to solve some of our most pressing problems. The success of Xinghuo could usher in a new era of global energy cooperation. No longer would nations need to compete for dwindling resources or be divided by energy politics. Instead, countries could unite around a shared vision of sustainable progress, working together to ensure energy security for all. Nations could collaborate on fusion research and development, sharing knowledge and resources to accelerate the deployment of this transformative technology. By pooling expertise and funding, the world could see fusion energy become a reality much sooner, benefiting every corner of the globe. Xinghuo is a beacon of hope, a testament to human ingenuity and our collective determination to overcome the challenges facing our planet. It symbolizes what we can achieve when we work together, pushing the boundaries of science for the greater good. It's a project that holds the potential to change the world for the better. With continued dedication and international collaboration, Xinghuo could light the way to a cleaner, safer, and more prosperous future for generations to come.